good morning. We are going to continue our lesson 8, and we are going to cover pages between 210 to 215. So today the title is Aluminium. We are going to focus on aluminium because aluminium is widely used by human and it's located in the periodic table in the part of transition metal or transition elements. We have done group 1 and group 2, so today we are going to move to the middle of the table, periodic table, um, which there are transition metals or transition elements are there. Aluminum is the most common metal in the Earth's crust, so Earth's surface. So that means it's very available for humans, and they can use for many applications, many things. So the one major ore of aluminum is bauxite, and um, so yeah, aluminum oxide also is purified by this ore. And let's look at some usefulness of aluminum. Aluminum, since they are light, a strong metal, and they have good enough electrical connectivity. So also they can be used for constructions, especially for windows frame, uh, because aluminum is the property that can resist against the corrosion. The corrosion can be happened by the water vapor available in air, or oxygen. So reacting with oxygen or water, actually water in form of gas, which is vapor. So that is corrosion. Corrosion mostly happen for for iron, not aluminum. Aluminum is protected against the corrosion, so that make it useful for constructing or building the windows frame. So um, also it can be a um, good choice for food packing, in regarding to make a foil container to to pack the foods. So yeah, there are many usefulness for from aluminium. And if you look at this picture, which is um, using usage of aluminium in USA, you can find by percentage of like 22% of aluminum can be used for building, which is the most, and 70% can be used for transport, like aircraft, because as I said, it's light and strong. So also for packing that I mentioned, about 16%, and so on. And there is a one type of reaction which is thermite reaction. So aluminum can be used to produce iron from iron 3 oxide. So later on I will explain about the valency of transition metal. Here I said iron 3. We also have iron 2. So transition metals can take different valency. I will explain later. But here, through this reaction, thermite reaction, we can get iron from aluminum. So according to this reaction, iron 3 oxide with aluminum, then we can get aluminum oxide, uh, and also it produce iron iron 1. So 2 iron 1. All right, and another one, yeah, this reaction is exothermic. We learned about exothermic before, and also this is a kind of reduction oxidation, which is called redox reaction. We also studied about this type of reaction or reduction oxidation in the previous lessons. So this called a termite reaction. The termite reaction is a kind of reduction oxidation reaction or redox reaction, which can be used for aluminum to produce iron. Also, it can be used as a same strategy to produce chromium. Chromium is another transition metal or transition element, but transition elements are all, they are metals. That's why sometimes it's called transition metal or transition elements. All right. Same as this strategy, also producing chromium can be used by reacting between chromium 3 oxide with aluminum, and then they produce aluminum oxide and chromium, which in form of powder S. And all right, analytical test for aluminum. When we are talking about analytical test, that means we are going to identify a kind of a certain compound or certain elements inside of the mixture, inside of the any chemicals. So here we are going to find a way how we can identify aluminum inside of any compound. So through this reaction, aluminum chloride and before this, I would like to explain that um, identifying the um, transition metals, it's mainly based on their color. Um, that means each transition metal is able to produce a certain color. So by this way, by identifying the color, so um, the type of transition metal can be recognized. So according to this this reaction, which we can get a white precipitate of aluminum hydroxide, then we can identify that the compound has contained of aluminum. The aluminum, aluminum ions, which is 3 plus, that means it's a cation, a positive charge. So it can be recognized if we add the sodium hydroxide to the compound that we don't know what is that. Okay, we have aluminum chloride. Okay, but you just imagine that we don't know that is aluminum chloride. We add sodium hydroxide. If we get a white precipitate, which is aluminum hydroxide, that means the compound is contained of aluminum cation. So this method can be used for calcium and magnesium also. Okay, this is analytical test for aluminum, but it can be similarly used for calcium and magnesium, which also they produce white precipitation. So what is the difference? How we can recognize aluminum if we have calcium and also magnesium? So the way which we can make a difference between aluminum with calcium and magnesium is if we add more sodium hydroxide here, okay, we have a certain amount of sodium hydroxide, but if we add more, then this aluminum can dissolve more also. So um, white precipitate will produce more and will dissolve more, but this would not be happen for calcium and magnesium. This is one unique feature of aluminum, and the way we can identify the aluminum ions. So this is also called amphoteric hydroxide. This behavior, this attitude of aluminum is called amphoteric hydroxide. The next part, which is transition elements. Okay, we already moved to transition element and looking for more kind of transition elements. There are some um, general properties for transition element, and we also there are some distinctive properties for transition element. Um, as a general feature of a transition element is they are much less reactive than the metal in group 1 and 2, which we studied in previous session, and they are excellent corrosion resistance like aluminum, and they have high melting point also. uh, so also some other major general properties, they are hard and strong, they have high melting um, points, which is repeated again here, and they have high density, and they have good electrical conductivity, and they are malleable and ductile. So another one is um, yeah, some a distinctive property of transition elements. They are colored, which I will explain some more about color, and they show some more valency, as I said, and they are very suitable to be used as a catalyst, and also some of them show a strongly magnetic, like iron, cobalt, and nickel. So um, here, if you look at this table, you can see each transition metal can produce different color. So different colors from transition metals are good way, is a good strategy to use for identifying the metal. Like after any reaction, if we receive like green color solution, that means the 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 chemical is contained of chromium 3, and as we can see, for example, iron are a kind of iron 2 and iron 3, which iron 2 produce different color with iron 3. About valency or valency oxidation state, valency is um, the the feature of the element shows you how many electron can be lost or can be obtained by the element. For example, here copper has 2 positive. That means the copper has lose 2 electrons. Here iron lose 2 electrons, and another iron lose 3 electrons. Sometimes they are negative, but currently we are talking about Metals are positive, positive positive ions. So um, for non-metal also they are negative, and valency can work for the negative charged ions like chlorine, like fluorine. They have a valency oxidation state. Valency oxidation state will tell you how many bonds can be made on copper. For example, copper, according to two positive charge, can make a two bond with the other elements. So this can be one valency of one for group one of the metals, like sodium has one positive charge, and potassium have one. So metal in group two, they show the valency of two, like calcium, like magnesium. So they have two. Aluminium is located in group three, so it shows you three positive, three um, three valence. But transition metal elements shows you difference. It's not straightforward like group 1, 2, and group 3. So it depends. They can receive 3 bond or 2 bond. They can show different valency, different color, and different property. So this called valency of oxidation state. And another property is catalytic property, as we learned before in previous lesson. Catalyst is the substance that help to the reaction, to rate of reaction to be speed up, but at the end this chemical will not be chemically changed, will not be used, okay, will not be used, and it will not be changed chemically. Physically they may change, but chemically they will not change. The structure, the chemicals will be same after the reaction. Another property is magnetic properties from transition metal, and three important magnetic metal is iron, cobalt, and nickel, which two of them are very available in Earth's surface in outer core. So presence of these type of elements in the Earth, the outer core or inner core, make produce the magnetic property of the Earth. So let's look at some reaction of transition elements. First, iron. Iron react moderately with the other chemicals. One thing that can help you, and I can give you this point, is um, there are some type of reaction which is replacement reaction. Okay, most of these reaction rely on the um, negative part or positive part of any chemical. As we know, iron is a kind of metal, and it can be positive, two positive cation can form a cation, and also these two element, which is hydrochloric acid, can be separated in any solvent, and then can produce a positive hydrogen and negative chlorine. So if we have one part positive and another positive and another negative, so this um, iron would rather to react with chlorine, actually replace with the hydrogen. Then at the end we will receive iron 2 chloride, and the hydrogen will be alone, can react to each other, the other hydrogen, and produce the hydrogen gas. So if you have this approach in your mind, then you can predict the reaction. Most of reaction is based on the replacement. If you recognize the positive part of any chemical and negative part of any chemical, so you can easily replace the elements and then predict the products. Another reaction under this category, like iron 2 chloride with sodium hydroxide. This is a base and it has two side, positive and negative. Sodium has it can produce a cation form, and hydroxide can produce an ion form, and this side also same. And then here iron can replace with sodium and react with hydroxide. Then it can produce the iron hydroxide, which is form of a participate, is like a form of solid, but the color is red brown. Okay, and these are almost same with the copper make a black layer of copper oxide if react with oxygen of air. That means um, we can say that copper is easily to be corrosion because it reacts with oxygen, so it will produce copper oxide. Any metal oxide like iron oxide, copper oxide, any oxide, if easily be obtained, that means that metal is corrosion. That means they can react with the oxygen in air easily. Um the best example is iron oxide. Iron, if you put the iron in a wet place or there is enough oxygen, so after a longer time they will be corroded. And this is same another example here, and also same with the zinc. Zinc is another a transition metal, and so according this, if but this is there is like a physical condition. If zinc oxide produced in a hot place, okay, hot environment, then the product zinc oxide will show you yellow color. But if the environment is cool enough, then it turns to the white zinc oxide. That means the product is related to the physical condition, temperature, and this part gives you lots of example, lots of reaction. I don't put all of this here. I just select some example to explain you, but please write down the reactions and try to make a list. Try to make a list of the reaction, and the most important, put the color, the color for identification. If in the exam on the paper ask you identify the color of this reaction, so you will be able to remember. This part is mostly based on the memorization. You need to memorize, make a list of the reaction, put the title, and write down the reaction, and put the color for the identification. So, and try to memorize many times. So this lesson is not the one to solve the equation or solve um, the things, but it's mostly related to the memorization. This lesson you should write and memorize many times. So that's all for today. Please look at the question number one and question number two, which is related to today's lesson, and question number three. Thank you so much. Stay safe at home. Take care.